Okay, so this video is to help you see the connections in everyday life to the trig functions that we've been graphing by hand. So in your notes on page 280, it gives you the set of data you can see on the screen. And what it asks you to do in problem number 1 is that you need to find the trigonometric models for both these cities. So what this data tells us is that T is the time or the month in this case. So month 1 is January, 2 is February, 3 is March, and so on. And then H is for Honolulu, so that's the temperature every month, the average temperature in Honolulu. And then the average temperature for Chicago is listed. So what you're going to do is you're going to need to get a calculator, and we're going to have to enter this data. Okay, so what we're going to do is, you're going to add a new document. And when you add a new document, you're going to add a list and spreadsheets. And when you do that, an Excel spreadsheet is going to come up. So any of you that have ever worked with an Excel spreadsheet, this column right here, this row right here that goes across that has a diamond at the front of it, that's the equation line. Like in Excel, if you press equals and then open parenthesis, you can type equations to do things as sets of data. We don't want to ever type anything right now in this row. I do want to go up top, and in column A, you need to title what this data set is going to be called. So if I were you, I would call it temp or temperature or month. In my case, I'm going to call it month, and I'm just going to type the word MONTH, enter. And then we're going to go over to up to where it says B, type Honolulu, and then in C, type Chicago. Okay, and once you put your months in, you're going to type your data sets in. So we're going to go past the diamond row, because it's the equation editor. You're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way down for month. And then you're going to go back to the top and start with the data set for Honolulu and enter every month. And as you're entering it, be careful because, for example, month 4 in Honolulu has to say 82.8. And then month 4 in Chicago has to say 58.6. Okay, so now that you have all the data in, to do number 1, part A and B, to find the trigonometric models, we're going to do the following. What we're going to do is we're going to press this blue second button, and then right here on the dock button it says plus page. So I'm going to press those separately. First I'm going to press the blue control button and then the plus page, and it's going to ask me what kind of page do I want to insert. This time I want to add a data and statistics because I want to use the stats that I just entered. And it's not going to look like much to you right now, but if you slide your cursor over to the side over here, it says click to add variable. Well, we're going to do Honolulu first because that's what it asks for first. So we're going to click. And it asks you, what do you want to put there? What do you want to put on your y-axis? Well, we want the temperature from Honolulu, which we called Honolulu. So I want to pick Honolulu. And that's pretty cool. The data points move. And now if you take your cursor and go down to the bottom here, you can't see it, but you'll find this box once your cursor gets close enough like that, and you're going to click, and this we want to call month because this was our independent variable, the time. And then look, you have this really cool, awesome data set. So you're like, okay, I've made this graph, that's amazing, but I need to find the model. So our calculator will do that for us. Press the menu button, and then what we want to do is we want to pick analyze, we want to pick regression. And then if you go down to letter A, it says sinusoidal regression. So it's going to make us a sinusoidal regression. And then it does it for us. And you can, if you take your cursor and put it close enough to the equation, it becomes a fist. And if you click the middle button right here, this middle button right here, and you hold it, the fist will close. And then you can move the equation around so you can see it. So we're going to write down the equation on our paper. Our equation was that y equals, I'm going to round to 3 decimals, 4.24, that's where it's going to end up rounding to, sine, open parenthesis, 0.511 x plus a negative, or you could write minus, 2.442, and I just slide it over just a little bit to see the last thing. Close your parenthesis, plus an 84.34. So now what you're going to do is you're going to pause the video and you're going to do the exact same thing and see if you can find the model for Chicago. So this should have been the model that you got when you did Chicago, 28.583, sine of 0.474x plus a negative 1.811, then close your parenthesis, and then on the outside, plus 55.708. So now we're going to do number 2. And number 2 says we're going to use a graphing calculator to graph the data points and model temperature in Honolulu. How well does the model fit? Well, we already used our calculator to find the model and do number 1. So to do number 2, hopefully you just added different pages, these different tabs up top, like I did. So if I press Control and then I arrow back and forth right here using these arrows back and forth, I can go back to my Honolulu graph. And if you look at the data points and the model that we have, the model seems to fit pretty well. There's these couple of data points right here that don't exactly fit, and a couple up here, but it's pretty close. And then if you arrow over back to the other page we were on, look at Chicago. Chicago's just a little bit better fit. If you're in statistics, you can use your R values and your R squared values to talk about exactly how close they are, but we're just gonna guesstimate and talk about how good we think they are approximately. So to answer number 2, I would say that both models fit pretty well. Chicago fits a little bit better than the Honolulu graph. And then for number 3, I definitely would mention again how Chicago was better. And there doesn't seem to be any kind of outliers. Like every point for Chicago is touched by our model, whereas Honolulu has a couple of data points. This one that doesn't touch, this one that maybe touches, this one up here doesn't touch. It's close, but again, it's just a model. Real life doesn't always happen in perfect mathematical form. And then we're going to get down to number 4. Number 4 says that we're going to use the models to estimate the average temperature, the average annual temperature in each city. And then it says, which term of the models did you use? And we're going to explain. So we're going to start with Honolulu to find what we think the average temperature is. And so I want to talk about this trig model for a second. This is my A value, my amplitude, how high and low I go. This is my B value, which is going to affect my period. This is my C, oops, I said C and I definitely wrote X, wasn't paying attention, sorry. This is my C value, my horizontal shift, and this thing down here is my D value. It's how far up or down the graph has been shifted from that 0 that it started on, and then it's also the line that cuts the graph in half. It's the middle. It's the average. So the D part of my model tells me the average temperature. So the average temperature in Honolulu is 84.341 degrees. And then we use that because, again, it's the middle, and middle is kind of like the average. So if you look at the Chicago model, that D value on the Chicago model is 55.708. So the average temperature in Chicago is the 55.708. Number 5 says, what is the period of each model? Well, remember to find the period of sine and cosine, we do 2 pi divided by our B value. And so before we actually do this, I just want to hypothesize what we think the period should be. So take a moment and pause the video and ask your neighbor what they think the period should be and ask them to explain why. So my hypothesis is that the period should be about 12 or 12 months because a year is 12 months long and every year is when the temperature starts repeating itself. So let's find out. So if I do Honolulu, I'm going to do 2 pi and I'm going to divide by my B value, which was the 0.511. And if I do Chicago, I'm going to do 2 pi and I'm going to divide by the 0.474. And so I'm going to use my calculator and find out what these two values are. So in using my calculator, I found out that the period of Chicago is 13 months and some change, and the period of Honolulu is 12 months. And so there are things like global warming and whatnot that can attest to that temperature difference. But from living up north, there are some winters that are colder than others, and there are some winters that are warmer than others. Sometimes you get more snow, sometimes you get less snow, and so it makes sense to me that Chicago has a different period that is bigger than the 12 months because every season is just a little bit different, and they have more of a drastic change between seasons. However, if you think about Honolulu, it's kind of always the same in Honolulu. The weather doesn't change a whole lot. It's usually pretty nice. And so having a period very close to 12 months doesn't surprise me by any means. To answer number 6, which says, which city has a greater variability in temperature throughout the year, which factor of the models determine the variability, and then we have to explain. First, you need to determine what part of the model we want to use, what part of the equations that we got from the calculator. So my recommendation would be to use the A values, the amplitude values, because the amplitude is how high and low you go from that middle line. Well, Honolulu, poor Honolulu, their temperature never changes. They only go up and down plus and minus 2.24 degrees from their 84.341 average. So Honolulu really, on average, on any given day, would be from 86, 87 degrees down to like 81 or 82 degrees. Really not that big of a difference. Chicago, on the other hand, has an A value of 28.583 degrees, which means that from the middle line, which our middle line, our average was 55.708 degrees, we're going to go up 28 and down 28. So Chicago definitely has a greater variability in temperature. They get snow, they have a true spring, they have leaves that change, but Honolulu, just nice and sunny all the time. And then the last question, kind of totally up to you. It says that spring break is the last week in March. Which city would be best? So March is the 3rd month. So you can pick, up to you completely. Do you want to go to Honolulu, where it's 81.6 degrees? Or do you want to go to Chicago, which is 45.8 degrees? And then here's just a brief recap of everything that we talked about and all the answers that you should have on page 280, which will be checked on Monday.